So in this video, I'm going to very briefly go over a proof of the product rule. The most important thing to get out of this video is what the definition or what the formula is of the product rule, which is that if I want to take the derivative, d dx, of two functions we'll call f of x and g of x that are multiplied together, then what I need to do is I need to take the derivative of them separately. So we'll do f of x and we'll do the derivative, which is f prime of x. What I'm going to do is I'm going to multiply it by the original other function, which is g of x, and then we'll switch. So we'll do f of x times the derivative of g of x, g prime of x. So notice again, we're going to take f prime times g plus f times g prime. So again, that's the formula for the product rule. That's the important part to get out of this. So what I'm going to do is I'm going to prove this by actually going back to the definition of a derivative using that limit definition. So I'm going to write it as the limit as h goes to 0. And we're going to plug in x plus h into both of those x values. So f of x plus h times g of x plus h. Then we'll go back and we'll still subtract the original function, which is f of x times g of x, all divided by h. Now, this proof itself is not a particularly difficult proof once you see the trick. And that's exactly my point. This actually has a little bit of magic sprinkled here in the middle. So I'm still going to do the limit as h goes to 0. And what I'm going to do differently is I'm just going to give myself a little bit of room, actually a lot of room, and I'll write the rest of it over here. And again, it's just a magic trick that I do to make everything work out nicely the way I want it to. So what I'm actually going to do is I'm going to add and subtract the same thing in this middle part of the definition. And since I'm both adding and subtracting, and I'll subtract first, they'll essentially cancel each other out. So I'm just adding in 0 essentially. But so what I'm going to do again is I'm just going to pull a little bit of a magic trick here, and we'll do f of x plus h times g of x here in the middle. And since I'm subtracting it first, I'm just going to add it in back here. So again, those two would essentially cancel each other out, but I'm adding them in for a specific reason. Now, here's what I'm going to do. I'm going to look at this first part of my limit definition, and I'm noticing that f of x plus h is in both terms, both parts of that. And so what I'm going to do is I'm going to factor that out of the first part. So I'm going to have the limit as h goes to 0 of f of x plus h times, now notice what's going to be left over after I factor. It's going to be g of x plus h minus g of x divided by h. And that's the first part. I'm still going to add, because there's my plus sign right there. And all I'm going to do is split up my limit. So we'll do limit as h goes to 0. And from this second part, hopefully you notice that I can factor out a g of x. So I'm going to factor out a g of x first. And that's going to leave me with f of x plus h from the first part minus f of x, the second part, divided by h. Now, hopefully at this moment you recognize that if I take the limit as h goes to 0 of that thing, that's actually the derivative of f. So let me write that down for a moment. So this is equal to plus. And what I can do, since there's no h here, is I can just take that g of x out. So g of x times the limit as h goes to 0 of f of x plus h minus f of x all divided by h. We again said that that was f prime of x. That's the derivative of f of x. So there's the first part. Notice that matches up with the first part of the formula. The other thing that I'm going to notice over here is that this g of x plus h minus g of x all divided by h is essentially my derivative of g of x. So the only thing I really need to worry about here is what this first part is, the f of x plus h. Well, if h is headed toward 0, that's going to head toward f of x. So let me write that down, f of x plus h. That's going to head toward f of x by itself. And I'm going to go ahead and again split that up and look at it from the perspective of g of x plus h minus g of x all divided by h. And that heads toward g prime of x, which is the second part of my formula. So again, notice we've got f prime of x times g of x plus f of x times g prime of x. And that is the end of the proof. Hopefully that helps you guys better understand where this formula comes from, and then it comes about, actually, mathematically speaking, it comes out from just the limit definition.